superheated mix of subatomic particles filled newly created space. As the opaque fog cooled, gravity collapsed the cosmic plasma into the first of trillions of stars and galaxies. As more stars were born, others died. Some ended their long existence in colossal explosions called supernovas. 5 billion years ago, one such blast spewed celestial debris into an arm of the Milky Way galaxy. Gravity quickly reassembled the massive dust and gas clouds into a new star, our Sun. Surrounded by swirling rings of residual rubble that chaotically and violently collided, fusing and growing larger, ultimately forming giant balls of fire. 4 of the molten masses cooled to form our solar system's rocky inner planets, including Earth, third from the Sun. But as fledgling Earth began to crust over, it was sideswiped by another young but smaller planet. The devastating collision destroyed the small body and melted it into Earth. The glancing blow also sent massive amounts of debris out into space. Those orbiting fragments quickly cooled and coalesced to become our Moon. And Earth began its evolution from molten hell to living planet. Remnants from the creation of our solar system bombarded the cooling crust. Those meteors and comets carried crystals containing water that condensed in the atmosphere and fell as torrential rain, cooling the planet and creating the first oceans, which held every drop of water now in Little Traverse Bay. Liquid, red-hot magma burst through fissures in the crust and rose up through the vast seas. The lava cooled to form thousands of chunks of land. The rocky chains were attached to distinct massive plates of the Earth's crust beneath the oceans. Over billions of years, the gigantic tectonic plates steadily drifted, shifted, and smashed the tiny islands together to create ever larger masses. Then continents, which in turn collided to form supercontinents. One of the earliest was Kenorland, which formed about 2.75 billion years ago, and included the rock that would become the foundation of North America, highlighted in green. But not until it and a series of subsequent supercontinents ripped apart, reshaped, relocated, and recombined. During the destruction and rebirth, North America was carried to the equator. There, northern Michigan was submerged for most of the next 200 million years, as great oceans invaded and retreated. The warm, shallow salt water exploded with life, including monstrous predators and extensive coral reefs. Over millions of years, the marine creatures died, fossilized and were compressed into the thick limestone that now underlies Little Traverse Bay, and includes the singular ancient coral that transformed into Michigan's official state rock, the Petoskey Stone. As Michigan kept drifting, land gradually uplifted and burst with life. Ferns carpeted swamplands. Eagle-sized dragonflies ruled the skies. And the precursor of all life on land moved out of the water. The evolution of life continued as Michigan merged with all of Earth's other land masses to form the last supercontinent, Pangaea. For the next 50 million years, a fascinating succession of species, dominated by mammal-like reptiles, roamed the expansive land. Then, a combination of catastrophes, including widespread half-million-year-long volcanic eruptions, led to the greatest of Earth's 5 mass extinctions. But again, a resilient Earth slowly rebounded with new life, including the first dinosaurs. The remarkable reptiles freely roamed across Pangaea until the Earth's plates again moved and began tearing the supercontinent apart. During the next 150 million years, the vast separate land masses slowly moved toward the world we now know. The dinosaurs successfully adapted to the dynamic geography. Some new species prowled new oceans. Others took to the skies. Those that remained on land evolved into a fascinating collection of creatures. Including the iconic Tyrannosaurus rex. Reptiles ruled the lands, including almost certainly Michigan. But again, a global cataclysm, this time the devastating impact of a massive asteroid. Rapidly led to the extinction of most large life, including all non-avian dinosaurs. But also again, survivors slowly took over the world. Over the next 62 million years, as Michigan literally inched to its present position, life dramatically diversified and steadily evolved along the path to thousands of modern species. But unfortunately, there are no fossil records to reveal which. What evidence that may have existed was scraped away by continental glaciers that slowly invaded and retreated over central North America 5 times during the next 2 million years. As they crept through Michigan, the immense frozen bulldozers gouged through channels that rivers and tributaries had steadily carved into the soft, 300-million-year-old limestone bedrock. And the tremendous weight of the ice, more than 2 miles thick in places, also depressed those areas to form extensive U-shaped valleys. As the last of the glaciers began a pulsating retreat from Michigan about 15,000 years ago, massive amounts of meltwater flowed into those basins and began forming the Earth's largest freshwater system. One of the largest river valleys would become the bed of Lake Michigan, and a 200-foot deep tributary ravine 400 miles up its east shore would fill to create Little Traverse Bay. But not until 12,000 more years of wild and complex fluctuations. Lake sizes, shapes, and levels changed sporadically as hundreds of ice lobes repeatedly thawed and refroze. And the Earth's crust, when and where relieved of the glacier's incredible weight, slowly bounced back. All happening in different places at different times. Early on, the newly exposed terrain attracted cold weather mammals that had crossed over from Siberia to North America thousands of years before. A fascinating menagerie of wildlife moved into Michigan, including a supersized beaver. At 7 feet long and 150 pounds, one of the largest rodents ever. Pig-like peccaries, musk oxen, giant moose, and magnificent mammoths and mastodons. And Michigan's first human inhabitants were close behind. But overkill by those Stone Age hunters, plus climate change soon, in geologic time, drove the unique animals to extinction. Their Michigan appearance lasted only a few thousand years. The glaciers also continued their disappearance, reshaping the lakes and land as they retreated north. And Little Traverse Bay was soon swallowed up by the largest ever Great Lake, Algonquin. About 10,000 years ago, Algonquin's high waters flooded Boyne Highlands and Nubbs Knob to create Brutus Island, the largest in an archipelago that stretched from Traverse City to Mackinac Island. But over the next 3,000 years, water levels dropped, separating Algonquin into 5 lakes with few connecting rivers. And Little Traverse Bay was dry. But not for long. Persistent flow from the still massive, still melting glacier refilled the bay and reconnected the 3 largest basins to again form a single Great Lake, Nipissing, about 25 feet above the present level. The meltwater also filled a small nearby glacial carve-out to create Walloon Lake and send its overflow into the bay as the Bear River. East of the bay, a series of smaller basins and channels also flooded, creating a long, narrow water body that joined Lakes Michigan and Huron. But that connection was soon severed when prevailing west winds mounded sand into a dune barrier at the bay's tip, and the remaining waterway partially drained and separated into several individual lakes, all still connected, and some still forming a water route to Lake Huron. The sustained winds also generated waves that combined with currents to form a finger of land that shelters one of Lake Michigan's finest natural harbors. Over the next 1,500 years, as erosion deepened the rivers between all 5 Great Lakes, plus a series of channels and drops to the Atlantic Ocean, they drained to their present levels and configurations. And Little Traverse settled in as the 4th largest bay, on the 2nd largest lake, in the most impressive freshwater system on Earth. And the last of the melting glaciers had not only filled the bay, but also sculpted every natural feature of the unmatched surrounding terrain. As the frozen bulldozer crept southward from Canada, it scraped and plucked everything off the underlying bedrock, then crushed and ground the embedded cargo into a mixture of rock, gravel, sand, and clay. During its final melt back north, the giant ice conveyor gradually discharged its load. Depending on how and where the pulsating lobes and fingers of dirty ice melted, they shaped the deposits, called till, into a mosaic of diverse forms and features. Large mixes from the ends and sides of slowly melting ice were piled into moraines, the highest of the hills that surround the bay. Heavy streams from rapidly melting ice at the ends of lobes sorted and spread till in the near-level, sometimes expansive outwash plains. Sediment that accumulated under the ice emerged as oval drumlins or longer, winding eskers, and waves from the Great Lakes' preeminent precursors, Algonquin and Nipissing, relentlessly chiseled their signatures into the deposits. Nipissing carved a conspicuous notch into 7 Mile Point at the northwest end of the bay. That alligator snout continues as an inconspicuous level terrace that traces Nipissing's shoreline through Harbor Springs almost to the bay's tip. A second, higher bluff, cut by Algonquin, carries Highway M119 through Harbor Springs north through the renowned Tunnel of Trees. In human perspective, water and ice had patiently and persistently applied the finishing touches to a profoundly scenic natural wonder created from stardust.